On this episode of Dirty Elbows Garage, we are back to working on the mid-engine car, and we're putting this 8-in-1 header collector piece to work. So let's get into it. This video is going to have a lot of cool design and fabrication techniques, but unfortunately the engine's not going to run in this video. The process of me building this car is going to finish out this exhaust system, then I'm going to order the engine parts to get it running, wired up, and I am going to get it running on this stand. But I wanted to get the exhaust done first. So if that's a big disappointment, you don't want to stick around, I understand. Feel free to subscribe and come back later whenever that video comes out. Now, if you're still here though, let's talk about how I'm going to use this piece on my mid-engine car. There are a handful of ways to get a header system or an exhaust system like this fabricated up. And with my goals of the car, and right now with this build, this exhaust system I'm treating as more of a prototype. I've never made an 8-in-1 header collector system before. And so I wanted to kind of explore some different options and see how I can accomplish this. I'm definitely running the engine on the stand, so it needs an exhaust system. And why not try it now? Of the few ways that you can get a system like this done, you can go and purchase a lot of the pre-formed components off the shelf. The piecing it way together is a great solution, but I wanted to try something different. I've got my tube bender here, so I kind of wanted to challenge myself to form every single part into one continuous run from the header flange all the way to the collector itself. So I've got a couple of ideas to do some flange work here to actually couple the left-hand side and the right-hand side together. But the primary goal is to use my tube bender to get that done. Now what that means is that it locks me into a particular radius. It's a pretty big radius in this example. It's a 5.5-inch radius. In the world of exhaust flow, that's probably gonna be really great because there's no sharp bends. It's got these real nice sweeping continuous changes of direction, but it's a pretty big design thing to get around to have that large of a radius in the exhaust system. So to see how I'm going to use this to get individual runners done all the way from the flange to the collector, let's go check out the CAD. All right, so kicking off the CAD discussion, where I began things was with the modeling of the 8-in-1 header collector itself. I need to get this into CAD, so I was able to position it relative to the drivetrain and then kind of develop how I wanted to split the headers apart. If you make everything one single weldment, you're locked in and you have to slide all of the headers off the machine. So everybody that does any kind of header collectors, they know that you have to split these things apart. And the majority of the time I see slip fit kind of things. I've decided to go with a flange-based setup where I'm going to have a flange that I create for the collector side, and then each header is going to have its own flange as well. And I'll just cut out my own custom gasket to fit that flange profile. As soon as this was done, I was able to jump over to my drivetrain. I was able to get it positioned and create those flanges, and that's what you see right here. So I've got my big flange that mounts to the collector itself, and then I have an example of my small flange that mounts to the header system or that left-hand side of the engine as well. Then I went ahead and did my simple 3.5-inch exit pipe to a 45 that kind of kicks up there. I didn't model the V-band clamp I plan to put right here, and I also did not model the O2 bung port, which is gonna have to go here as well. So the idea with putting a V-band clamp right here is that I expect this thing to be pretty loud and I want interchangeable exhaust setups. So what I can do there is I can put a straight run muffler or resonator, or I can kind of get creative with what's needed in that area. So that's the plan there. With this part of the exhaust wrapped up, I was happy to move forward to the header flange itself. So this is my header flange. I just made it in context to the 3D scan of the engine. I double checked some measurements to the actual engine. I probably could have pulled the DXF online, but the whole purpose here is that we're trying to do this from scratch on this engine. So I was able to get that done. I'm gonna have to do some cleanup work with a grinder in the future, possibly to kind of get rid of or get around some more holes features, maybe even some spark plug openings. But for the most part, it's gonna work out pretty well. So a design technique I regularly use and highly recommend is to do a top-down design. What that means is to kind of establish your top level assembly, then kind of build out your subs below that, and then the parts within that. So at no point am I starting at the low level, I'm starting at my top level, and I'm creating the tree of all the components and things that I'll need. So over here you're gonna see the drivetrain itself, the left-hand exhaust system, which you see is the parts that just highlighted blue. At the right-hand side, nothing's there. And then I've got my weldment collector weldment, the collector weldment itself. And then I also have the intake manifold. Now I 3D scanned this intake manifold because I had to use it as part of the design criteria to make sure that all the headers dodged it and also gave it enough room for heat and things like that. Yeah, so let's jump into that left-hand exhaust manifold weldment. So when I started modeling this, again, this is my starting point down here with the headers, and this is my end point with the collector. And my first version of this, I just started to freehand it. What I did is I just opened up a 3D sketch in each of these part profiles, and I just wanted to see, you know, what could I do with the bins here? What can I do with the bin profiles and matching that same 5.5-inch radius that I've already decided that's the route I'm gonna go. So I just started drawing some things up to kind of freehand what something might look like. Was not happy with this. It did not capture the symmetry I wanted to get. Manufacturability of this is a lot more complex than it should be. So even though this isn't the best design or the most manufacturable and it's not symmetric, it's not what I wanted it to be, I was able to kind of prove out my 8-1, the equal length part of that, to be a success. So up here, there's SolidWorks has this feature called sensors. If you've used this before, they're kind of cool. What you can do is you can effectively tie a length or a profile of measurement to a feature in your design tree, and it's going to automatically update as you change certain features or as you redo some geometry. It'll look at that same sketch and it'll update that value. So that's what I did. I created a sensor for cylinder 1, 3, 5, and 7, and you can see I've got 0.1 and 0.2. So every time that I'd update this geometry, these sensor values would change, and I was able to keep a close eye on how well or how balanced my design was to capture that equal length part of it. I kind of gave up not too far into working on this part of it, and I moved on to version 2. So let me go ahead and hide version 1 again. Okay, so as you can see, this one's a lot more symmetric. If I look at my sensors up here, they are a lot happier, but everything was really close as far as being equal length. And the way I actually modeled this up was I did everything in one sketch down here in my 3D layer head out sketch. And I just kind of set some parameters, one off the ground, one off the engine, the lateral midplane I call it. And that really is what drove the geometry. That ensured that it kept it kind of symmetric, and I was able to kind of move forward, dodge the intake manifold, and kind of just check all the boxes. It's equal length, it misses all the geometry it should miss. It's simple to manufacture. It's got 3 bins as opposed to all the other ones. And I expect it to kind of give it this cool like rib design layout whenever it's done, and kind of be a success in that regard. Back to the drivetrain now. You can see that header set up there. And what I did, just to kind of give a sneak peek to myself, is I mirrored it. Now, it can't be an exact mirror because the exhaust ports on the engine are not exactly aligned with each other across a longitudinal midplane. So I am going to have to play with the design a little bit more, but I'm going to do my best to make it look symmetric while also find that balance of equal length and kind of just maintain that. It can't be perfect. It has to have a little bit of asymmetry to it. And there's probably some asymmetry that's going to happen with the manufacturing as well, but this is it. So let me work on that other side. I'll meet you back out in the shop and we'll get to fabricating soon. Now, one of the things I didn't mention in CAD was that when you're working with sheet metal tools, the sheet metal profiles in SolidWorks will account for stretching or the material actually growing in length as you form it. Using a sweeping tool with formed tubing, it's not going to do that. It doesn't account for the material stretch. So I have to allow for run out. And what I'm doing is I'm leaving run out on the side of the collector. So everything is to cut to length starting at the engine side, and then I have run out at the end that I'm going to trim the length as I get to that point. So basically all the lengths, all the bins are going to be there, and the lengths between the bins are going to be dialed in according to my straight line measurement. I expect some flexing to happen in there, but it should normalize out across the bins, across everything. They should all kind of grow almost the same. Everything should lengthen relative the same. So yes, the entire step's gonna get longer, but it's gonna get longer together because all the bins are within about 5 degrees of each other anyhow. So that stretch is gonna be consistent across the entire thing. So really, I just gotta get all the bins done, and then I'm able to just chop off the extra length to what it needs to be. One other thing, and this is deep down the rabbit hole, but if you're interested in exhaust resonance tuning, I'm looking at getting a boost in volumetric efficiency based on resonance tuning of this exhaust system right around the 3000 RPM mark. So it's kind of worked out in two ways. It's something I was cognizant of going into the design. I wanted to make sure that it wasn't going to be a really peaky power band adder or something really low in the RPM range. It just happened to fall in the 3000 RPM range really well with just the natural way I was setting up the geometry. So I'm really happy with how that came out. So whether or not I'm going to see that effect massively kick in like on a dyno or anything like that, that's to be seen. But if you're interested, there you go. About 3000 RPM is where we're going to see some exhaust scavenging effect happen. So let's get back to some fabrication. So just like you saw in the model, I have my header plate for the left-hand side of the engine. I have my left-hand side for my 4 collectors that are gonna end up on then the 8-in-1 collector flange plate. So what I've done here, or what I'm working on now, is I have 3 pieces of angle iron that are going to position where the 8-in-1 collector is going to go. I'm going to get these measurements just right off of the transaxle as well as off of the engine, and then the angle is set by how I cut these pieces of angle iron. I put the 30-degree angle onto them so that when I bolted it here, I didn't have to worry about that. I just need to make sure it's level. So the reason for having this flange here is exactly why a lot of guys are going to mount a turbo in space and then have something to go to, because you really want to have your beginning and your end points, and then you can kind of tweak things in the middle as needed. So anyways, we're ready to get going on the exciting stuff. Let's cut some piping and get to bending. The way that this tube bender works is that it's got these little pins that you pick up and kind of reset the position. You catch your tubing in here. We're measuring to the front side of every bend. So where the bend begins, that's where we pull it through to kind of a stop to start the bend length. So when I'm actually creating the profile from taking the 3D bent parts to a 2D part that I can actually measure out, what I'm measuring is the chord length or the center line length of that exhaust tubing piece. And I'm looking at the starting point of all my bends. And I basically just take a straight section of tubing, I mark it up, and then I start bending it. Now to mark it up, I 3D printed up this pretty cool little part. I'm kind of proud of it. I'm able to squeeze it, it grabs onto the tubing, I'm able to mark it, and it's just wide enough to kind of create that flat section to help everything stay perpendicular to the axis of the tube. Okay, so I have my left hand and my right hand header are both complete. I was able, well, as far as tacking it goes, I haven't pulled it off to actually fully weld it yet, but tacking it is good to go. I was able to pull up the support back here, and now I'm ready to start on the 8-in-1 collector itself. So I have two of these. The first one, if you can see right here, it was actually dented in shipping. The company already made it right. They get me a new one. They said, go ahead and just keep this. So I did. And the idea here is kind of like I said before, I don't anticipate this is going to be the final exhaust system. So along with that train of thought, I'm going to go ahead and cut this one. I'm going to flare that back out so it minimizes the hole or the gap that I need to fill. And I'm going to repair this so that I'll have the other one when I'm ready to do the complete system in its own way. So let's get to work on this so that we can keep everything going. All right, so I've got the collector welded to my flange here. I've done all the internal welding, so I know that all my exhaust gases are sealed off now. What I'm going to do is I'm going to flip it over. I'm going to seal up those two openings I created to straighten out that piece, but I'm also going to go ahead and add a fillet weld to the outside of this, partially for cosmetic reasons, because it's just going to look sharper if it has that fillet weld there, but also for strength reasons. Again, this kind of sealed the gas flow, but I want to make sure that the entire flange, including the areas around these pickup points, are going to be really rigid to kind of minimize any kind of flexing. So time to flip it over, get that on there. And then also I've got my 3.5-inch V-band clamp. So there's actually the entire setup right there. It goes together. So one of these pieces is going to get welded to this, and the other piece gets welded to a 3.5-inch long or 3.5-inch diameter tubing section. So we'll get to that in a minute. So all the welding is now wrapped up. For the flange to header portion, I went ahead and did a fillet weld around the outside of the tubing face. For the flange to the collector piece, the half semicircle pieces, I did a kind of a butt weld, mostly just fuse welding on the internal of that face there to kind of make all the gases sealed into that flange. And then I did maybe a 1 or 1.5 inch long fillet weld on the outside for structural purposes. And I kind of repeated that process just like I did in the collector itself. I did a bunch of fuse welding or inside butt welding to the 8-in-1 collector. I've got the 3.5 inch V-band clamps welded to the collector and then to my section of pipe or my section of stainless tubing. And then I also have the little 45 kicked up, and that was fuse welded as well. It doesn't need to be structural or anything like that. Pretty simple, straightforward stuff. So that's all done. Let's get it reassembled and see what this beast looks like. All right, it's the next day, and I spent way too long just staring at this thing last night. I'm so happy with how it came out, and I can't wait to hear the thing run. I do want to talk a little bit about the fabrication, how that all kind of turned out. Out of all of the headers, or the actual piping, I had 3 scrap pieces. Now the first one I cut to exact length, and you can kind of see at exact length, the piece actually fell off the back of the die and it kinked the tubing. So that kind of caused me to scrap that one. The other 2, I have a paper around here somewhere. As I finished these, I had a target of a certain tolerance to hit as I was forming all the tubing, angular wise. And you saw how I kind of formed it, where I bent it around, flipped it up, and then kind of, there's 3 phases of that. My goal of the forming of the tubing itself was to achieve plus or minus 2 degrees on every single bend and bend plane. When all was said and done, I only had 2 pieces that were outside plus or minus 1 degree. So it was so much better than I thought it could actually achieve, just from taking my time and kind of studying the spring back on the pipe and things like that. That I decided to scrap those 2 and then remake them to the same tolerance that everything else was functioning at. So everything you see here is plus or minus 1 degree as far as the bends go, and then outside of the plane work as well. So that kind of turned out great. The overall manufacturing process of this all in all, I would say that if I were to start from scratch and finish this project, it would be about a 3-day build. Forming this stuff is extremely fast if you're able to kind of form this tubing yourself, and cutting out the flange work, things like that, positioning it, that's not a big hard thing to do anyhow. So as far as getting an exhaust system like this done quickly, I think it's a pretty cool way to do it. In the future, if there's a next version, if I can't get body work or whatever else to fit around this beast, I might end up doing the other method where I get some smaller radius bins and kind of piecemeal it together more, just to explore what that kind of build is like versus this one. But ultimately, this has been a huge success. I cannot wait to hear this thing run. Engine parts are already on order. You've probably noticed I didn't put all the hardware in. That's because it all has to come back apart. I've got a cam swap to do, the displacement on demand, and the active fuel management system and variable valve. All that stuff's getting deleted. So those parts are actually on the way by the time you're watching this video. And when they come in, all this has to come back off. The engine transmission getting split apart. We're working on the engine. We're gonna get the flywheel in the transmission, the flywheel in the clutch and the transmission, and then it'll all come back together, and then we'll move on to other stuff from there. So feel free to like, subscribe, all that good stuff. There's tons more content on this project. Even before we get back to the engine, I'm gonna start diving into the CAD. I've got a steering rack ordered. You saw I did the power steering study, so the whole steering system's really getting dialed in. My suspension system's getting dialed in. I even started drawing up some chassis work. So if you're interested in all of that, again, feel free to like, subscribe, all that good YouTube stuff, because there's a ton of cool things coming out soon, and I'm excited to share it. So with all that being said, thank you so much for watching. We'll see you next time.